Lesson 84, Identifying Quadratic Functions. A quadratic function can be written in the form, and they have f of x, which we know to be the same as y, equals ax plus bx plus c. Okay, remember we talked about this being standard form for our trinomials. Okay, this is standard form for a quadratic function. And it says where a cannot be equal to 0 because we have to have the x squared term for it to be a quadratic formula. So this is the quadratic term. The linear term is where we just have b to the x, or bx where x is to the first power. Okay, we should know that as being linear. Whenever I graph y equals mx plus b, that is a line. Okay, and the constant term is c because this is just any number that they plug in there. Okay, it doesn't change because it's just a number, no variable with it. This is called standard form. I just said that. And a quadratic function, they all have a degree of. Remember, whenever we have multiple terms, the degree of the function of the whole thing is the highest degree that they have. Remember that the degree is the sum of the exponents of the variables. So here, a represents a number, x is a variable and it's raised to the second power, b is a number, x is a variable raised to the first power, and c has a degree of 0. So the highest degree here is 2. So it is that they have a degree of 2. On example 1, it says determine whether each equation represents a quadratic function. So what we're going to do is we're going to get y by itself. So I'm going to add 15x squared to both sides because I want y by itself. So those will cancel. I'm left with y equals, and I want to write all of this in standard form. So I have 15x squared, that's that one, I didn't put a plus because it's understood, plus 2x, and then in front of the 3 here, there's no sign which tells me that it's a positive. So do I have a degree of 2 for this one? Yes, I do. So this one is, yes, it is a quadratic function. Here, I want to get y by itself again, so I'm going to add 62 to both sides. I'm going to add it to its like term on the other side. So I have y equals 3 plus 62. Well, let's write it in standard form. How about? I have negative 2x is going to go first. These 3 plus 62 gives me a positive, so positive 65. Do I have a degree of 2? I don't. My degree here is 1. This one would be linear. And you should be able to see that this is in slope-intercept form. Y equals mx plus b. On C, again, I want to get y by itself. So I'm going to subtract 8x from both sides. It doesn't have a like term over here, so those will cancel. I'm going to switch sides of things. So I'm going to have y equals, on this side, I'm going to take the largest degree first. This one is 9x to the 4th. So I have 9x to the 4th. Then I would have minus that 8x. Minus 9. Does it have a degree of 2? No, it has a degree of 4. So this one is not a quadratic function. Not a quadratic function. On this example, it wants us to graph f of x or y is equal to x squared because it's the parent function. So what we're going to do is we're just going to choose some numbers on both sides of 0 and 0 itself. So I'm going to go with we'll say negative 3, negative 2, 0, 2, 3. Okay, pretend like those look nice. So if I plug in negative 3 here, well, negative 3 squared is giving me a positive 9. Negative 2 squared gives me a positive 4. 0 squared gives me 0. 2 squared gives me 4. 3 squared gives me 9. So I just need to plot these points. So I have negative 3, 9. So left 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then left 2 up 4. So left 2, 1, 2, 3, 4. 0, 0. 2, 4. So right 2 up 4. Then 3, 9. So right 3 up 9. Okay? So my graph, ooh, if I can hit all my points. No, that's pretty close. My graph looks approximately like this. And we call this a parabola. Okay? It's the U shape. It should be more circular, rounded than what it looks. Okay, it should look like a nice U. My graph isn't fantastic. It's hard for me to trace on this thing. So that's a parabola, and that's what the parent function looks like. So it says to use a table to graph this function. So we're going to do the same thing. I'm going to choose some a negative, 0, positive, that sort of thing. So I am going to choose, I'm going to go with -2, -1, 0, 1, 2. Okay. So if I plug in -2, I would have -2 squared times that 5 minus 3. This would give me 20 minus 3, going to be 17. Here I plug in -1. Let me move this. So if I plug in 5, -1 squared minus 3. So this is going to be a positive 1 times 5. 5 minus 3 is going to give me a 2. Okay, if I plug in 0, it would just cancel that one out, so it gives me -3. If I plug in 1, because I'm squaring that, it's going to end up with the same thing if I plug in -1, which we said was 2. And the same thing with 2. 2 times 2 is 4, times 5 is 20, minus 3 is 17. So whenever I plot these, -2, 17, I'm going to go left 2, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. -1, 2. So -1 up 2. 0, -3. So 0 down 3. 1, 2, 3. 1, 2. And 2, 17, which is about here. So again, whenever I make my parabola, I'm going to try my best to hit those points. Oh, I'm not very good. That's roughly what my graph should look like. Okay. Notice that it's skinnier and that it dropped down 3 units. Okay, so I didn't skip one, did I? No. So the direction of a parabola says for a quadratic function in standard form, y equals ax squared plus bx plus c. If a is less than 0, numbers less than 0, what are we talking about? Hope you're thinking negatives. Okay. If a is negative, the parabola opens downward. If a is greater than 0, those are positive numbers. So if a is a positive, the parabola opens upward. So looking at the last one that we did, a, okay, is right here. This 5 is a positive number. It opens upward. If it had been negative, it would have opened downward. So on this one, it wants us to determine whether each graph opens upward or downward. And all we have to look at is a. Because if a is less than 0, or if it's negative, it's going to be down. And if a is greater than 0, which would be positive, it opens up. Okay? So, looking at this, I know it's always in the form of ax squared plus bx plus c. I'm looking at a. In the place of a is this 3. 3 is a positive, which means it opens up. We'll say upward. Okay. On b, similar situation here. It's not in standard form, so I need to write it that way. So I have f of x equals, my first term would be the square term, so I have minus x squared, or negative x squared, minus 10x, and then this has nothing in front of it, so it's positive 15. So now I have ax plus bx plus c, ax squared, how about that? And whenever I have this, my a in this case, it just looks like it's negative. Well, it's an understood -1, right? So if it's negative, where a is less than 0, that means that it opens downward. And that's my final answer. Last example here says Quan drops a marble from the top of a 30-foot water tower. The equation 33 minus h equals 16t squared can be used to find the height, h, of a marble after t seconds. Find the height of a marble after it falls for 1 second. So I'm going to rewrite this equation. 33 minus h equals 16t squared. I want to find h, right? So I'm going to subtract 33 from both sides. Those will cancel each other out. I have negative h equals 16t squared minus 33. To get h by itself, I know there's a negative 1 in front of it, so I'm going to divide by negative 1 on both sides. So I have h is equal to 16 divided by negative 1 is negative 16t squared. Negative 33 divided by negative 1 is positive 33. So after 1 second, t is seconds, I'm going to plug in 1 for t. H equals negative 16. Instead of t, I'm going to put 1, square it, plus 33. I want you to find that final answer on your own. Hope you've taken good notes, and I will see you in class tomorrow. Have a good night.